We have found that running, especially if you're really doing an advanced 5G network, that it can cost you somewhere between $100,000 to $200,000 a month to run, operate, and manage one of these facilities. And that's even if somebody else is paying for the capital, which often happens with academic organizations through either federal or state grants. Well, if you look at it, then you've got manufacturers and developers and stuff like that that have got systems that they want to go out and test, and they want to go out and want to go ahead and research, but really need a platform leading environment to really be able to do that. That's again where these labs end up coming in. I kind of equate it to, you've got a developer, and that developer really has got a small piece of the 5G ecosystem. And that person doesn't want to build the entire 5G ecosystem just to really do what they need to do. Kind of liken that to about a year or so ago, I was talking to the former CTO of the FCC and complaining about my broadband service at home. And he was saying, well, you got the wherewithal. You can basically build your own network, and you can become your own service provider, and you can make all of your neighbors happy. And I'm going, yeah, but I really want to go to a restaurant and buy a meal. I don't want to own a restaurant. So for the folks that kind of have that philosophy, that's why these things have been put together. So what ends up happening then kind of at the end of the day is, so you've got these resources there, but of course, all of these network resources need to be connected together. So what types of resources do we have to really provide those connections? There is a national R&D, research and R&E, research and education network. It's funded significantly by the Department of Commerce back in 2010, which is the Internet 2 network. They do a lot of very specific type research and testing now. They provide the network for very specific type of research and testing now. For example, if you're a high energy physicist and you're doing work with a large hadron collider in CERN, Switzerland, when they do that testing, that creates massive amounts of data. So how do they end up really basically getting it back into their labs to really do the analysis of that data? That's across networks like the Internet 2, which by the way has global reach. And more recently, another network had been funded, this one by the National Science Foundation, which is called Fabric. So Fabric is really kind of the same collaborators and everything else, except for Internet 2 basically is running on up to 88 100 gig waves that are connecting academic institutions and labs all over the United States. The new network, basically the Fabric network, is designed to run terabit per second waves. Again, there's not very many applications that really need the type of latency, low latency connectivity, the types of high bandwidth capabilities. Not a whole lot of applications that really require that. But when you really start doing 5G work, especially across organizations, that's the kind of bandwidth and throughput that you're really basically looking for. So those resources are out there today, they already exist. So the big question for everyone then is how do we leverage them? How do we take advantage of them? Those are that's one of the areas that I think you're going to probably see things like, for example, the things like the labs across America working on trying to figure out.